Alright, so this will be our last section of new material in Chapter 3, and it's another money section. In Section 3.5 we did loans, and maybe you're more familiar with loans than savings. In this section we do savings, and I could have broken this section into two sections, but I left it as one. Kind of the first half of this section would be like saving for retirement, and then the second half would be spending your money that you had saved once you're retired. And it turns out that calculator wise the problems are different when you're saving up as opposed to when you're spending your savings. Different in terms of the signs. Also different in this section is that the PY and the CY aren't going to be constantly 12. Generally when you're making some sort of loan payment, usually you make monthly payments. So there are times where you make payments every 2 weeks, but that's not nearly as common as having different time frames for the PY and the CY when you're saving for retirement. Most people at some point in their life start saving for retirement by getting money taken out of their paychecks. And when you get money pulled out of your paychecks, the PY and the CY for that problem, if you're trying to figure out how much you're going to have saved when you retire, can't be 12 unless you get paid once a month. So when we get deeper into this section, we'll talk about what other PYs and CYs might make sense in the context of specific problems. So let me go through some of the TVM solver screen numbers that will work for savings problems. And then, so the N is kind of consistent. It's the total number of deposits that we're making in a savings problem. So in loan problems, it was the total number of payments, and it's not really any different. Usually the N in savings problems is going to be the number of years times the number of payments per year. And that's kind of what it says here. It's the number of years times the number of payments per year. And that won't be the confusing part of this section. Nor will the I, which is the interest rate. These really don't change. What does change is the PV in terms of it's not always positive. In our loan problems, the PV was a positive for 100% of the time. And in this section, when we're in the loan section, the PV was the loan amount or the amount that we owed on the loan. In this section, when we're saving money, the PV is the amount of money that we already have saved up. And the horrible thing is, its sign depends on what you're doing. While you're saving money, the PV gets a negative sign. While you're spending your money after you're retired, it gets a positive sign. So I'm just making note of this right now, that the PV can have different signs depending on what you're doing. Negative while you're saving, positive while you're spending, and we'll get into the examples and I'll show that better than just saying it. So you don't have to have that memorized now, but just be aware that in loan problems, the PV was the loan amount, it was always positive. In savings problems, the PV is the amount of money that you have saved up, and the sign that the dollar amount gets depends on whether you're saving up money or you're spending your savings. Similarly, the payment has to do with the amount of money you're depositing into your retirement account or the amount of money you're pulling out of your retirement account. And again, because we're doing both scenarios, saving up for retirement and spending for retirement, the signs need to accommodate both scenarios. And so when we're saving money, the PMT is going to be negative. While we're spending money, the PMT is going to be positive. And again, we'll get to that deeper when we get further into the section. So those $2 amounts, the PV and the PMT, the signs can fluctuate depending on the problem. In loan problems, the FV was always 0 because I always wanted to have the loan paid off. Well, the FV in savings problems will won't be 0 very often, because usually the future value is what I want to have saved up in the future. In a loan problem, the future value is what I want to owe after the vehicle's paid off or the house is paid off, which is 0. But in savings problems, that's the money I'm saving for retirement. So hopefully it's not 0 while you're saving. And then, but it's only entered as a positive. At least we don't have to worry about sign fluctuations with the future value. The PY and the CY are, I'm always going to make them equal to each other. It's probably oversimplistic making them equal to each other, but it's already more complicated than it needs to be for some students this section, so I won't add that layer of complication. But the PY in this section, so the PY and the CY will be the same for all the problems. I mean, whatever the PY is for a specific problem, the CY will be that. The PY is going to change from problem to problem based on the information that's given in the problem. And there are some numbers or some words on the following sheet that will help us figure out what numbers to use for the PY and hence the CY. And just like in the last section, I'm going to leave my calculator on end. That we won't fluctuate. So when we're saving up or spending our retirement money, there's 4 different numbers that the PY might take in our problems. I guess theoretically, you could take 365 different numbers, but because there's 365 days in a year, maybe even more than that. But nevertheless, for us, when you're retired, you usually don't get paid every 2 weeks. Like my parents are on Social Security, they're retired, they get paid once a month. And if I see the word monthly in a savings problem, then it's going to be the same PY and CY that we always have done, which is 12. The tricky ones is while you're saving for retirement, I get paid every 2 weeks, and there's 2 months out of every year that I get 3 paychecks, and they're like the best months of the year. So like usually kind of May is one of the months I get 3 checks, and then I want to say November might be the other one, maybe it's December. This year it fluctuates. This year it was November that I got 3 checks. So if you're saving for retirement and you're getting paid every 2 weeks, then the PY and the CY is 26, because in this kind of pay, there are 2 months each year that you get 3 paychecks. The other way people get paid is they get paid like on the 1st and the 15th of each month. And if that's the case, the PY and the CY are going to be 24. And in this case, you never get more than 2 checks. You get 2 checks every month, and you never get the 3 checks. So my brother gets, and myself, I get paid like this. My sister-in-law gets paid on the 1st and the 15th. I don't know that one is better than another, but I like getting those 3 checks, those 2 months out of the year. And then some of the really simple savings problems, we're going to make 1 deposit per year just to make the numbers work a little bit easier. So it's going to be really important as we go through the savings problems to differentiate between every 2 weeks, where the PY and the CY are going to be 26 compared to twice a month, where the PY and the CY are going to be 24. And I almost guarantee myself that sometime during my lecture today that I'm going to make a mistake, and I'm going to see one of these words and choose the wrong set of numbers, even though I completely understand what numbers belong. It's just, for whatever reason, when you see 2 or twice, all of a sudden I don't know, they become confusing. They start to look the same. So I'm going to keep this sheet handy, and I'm going to keep glancing at it as I go through the problems, just to make sure I don't make a stupid mistake and have to record the whole video again because I have, you know, more than one error. And that hardly looks like paychecks there. All right, so now we're probably ready to get into some beginning problems. So first example, $100 is deposited every 2 weeks, and immediately when I see that word every 2 weeks, I think, oh, in this problem the PY and the CY are going to be 26. So it's probably not a bad idea in these savings problems to just target the PY and the CY first. The nice thing about the savings problem is we're never going to leave the TVM solver screen. So I'm not going to have to do like the balance or the sum of interest like that we did in the last section. So immediately as I read through these savings problems, for me, the PY and the CY are places where I'm going to screw up. And if I see every 2 weeks, the PY and the CY are 26. If I see twice a month, the PY and the CY are 24. So in this problem, the PY and the CY need to be 26. Now I can dig into the problem a little bit further. So the first number I see is $100, and it's deposited more than once. If you have a recurring equal deposit, that goes in the payment, and while I'm saving, it should go in as a negative. So this $100, because it's not just a single $100 deposit, it's a recurring $100 deposit, goes in the payment, and while I'm saving, money gets, the PMT and the PV go in as a negative. So while saving, and that's what here, I'm building my savings, the PMT and the PV are both negative. And that's this kind of problem. Now in this particular problem, I only see $1 amount, and there's 3 different places to put dollar amounts: PV, PMT, and future value. The PMT gets the 100 because I'm making more than one deposit. And let me go through and fill in the other numbers, and there's going to be 2 blanks. The PV and the FV are going to be blanks. One of them is going to be 0, one's going to be something I'm solving for. The next number I see in the problem is a 5% interest. That's easy. It goes as the 5. And the only other number I see in the problem is the 25 years. And if I put 25 in for the N, that would say I'm only making 25 deposits. But I'm making 26 deposits a year for 25 years. So the N in this chapter, or in this section, is always going to be the number of years times whatever the PY is. So in this particular problem, it's 25 years of 26 deposits per year. And if you multiply those on your calculator, I'm going to multiply them again to make sure I did that right when I wrote this material. But 25, let me clear out all this. 25 times 26, it is 650, but you can't see it, I can see it. So the N is 650. So I've taken care of the $100 for the payment. The every 2 weeks gave me a PY and a CY of 26. The 5 gave me an interest rate, and the combination of the PY being 26 and the number of years being 25 gave me the N at 650. So what I'm trying to find now is the balance after 25 years. I'm actually trying to solve for the balance, not the present value. Right now there's apparently no money in the account because I wasn't told how much money was in the account. So in this problem, I'm solving for the future value, and I have no numbers left in the word problem itself, but I have a blank. And when that's the case, when you know what you're solving for and you're still missing an amount, the other amount has to be 0. And the PV would only get a value if, while I'm saving, if the account already had some money in it. So if I go to my TVM solver and enter these, so I'm going to go apps, finance, enter on TVM solver. type in 650 for N, 5 for my interest rate, 0 for my PV, negative 100 for my payment. Move down to the PY. When I type 26 in for the PY and hit enter, it's going to change the CY for me. My calculator just is programmed to make those the same. You could override that if you want by going down and typing a different CY, but we won't have the need. We'll keep the PY and the CY the same just to keep it simplistic as we can. So I have everything entered. Now I want to solve for the future value. So I cursor up to the future value, get my cursor flashing there, then I hit the alpha button and then the enter key, and this person's going to have, after 25 years, putting $2,600 away a year, that's $100 times 26, they're going to have $129,280, and we'll round that to 10 cents because that's 9.7 cents, and we round it up to 10 cents. So this is what the first problems are going to be like. Exactly the same answer, so I feel good about that. So homework 1 through 4, they have a part A and a part B just to kind of really hammer home the benefit of saving for a long period of time. If you're saving money for 10 years, it doesn't really matter. Well, it matters how much you put in, but time is almost more important than the amount of money that you put in. So when you do problems 1A and 1B, the 1B is going to be more than 3 times 1A. Even though the length of time is only 3 times, the amount of money is going to be way more than 3 times. So when I go to do 2A, I'm going to use the TVM solver screen. So I know I need to type in an N, an I, a PV, a PMT, a future value, a PY, a CY, and I'm going to leave my calculator on end for all of these. The first thing I'm going to look for is I want to get the thing that I make a mistake on, the PY and the CY, and for every 2 weeks the PY and the CY are going to be 26. So in my problem, as well as your problem number 1, the PY and the CY should be 26. Now I'm going to dig into the problem. The first number I see in the problem is $300, and it's a recurring deposit. I'm depositing that every 2 weeks, so it's a PMT, and while I'm saving, the PMT should be negative. The next number I see in the problem is the 7% interest. I'll put that in for the I. And then in part A, I want to find the balance after 10 years. And so my N is going to be 10 years times 26 payments per year. And if you do 10 times 26, you'll get 260 for the N. I've used up all the information in the problem plus the extra bit for part A. And I have 2 blanks, just like in the example I have 2 blanks. I'm solving for the amount of money that we have in the future, and the other dollar amount, since it's not given, has to be a 0. So I'm going to enter those on my calculator, and that will give me my answer for part A. My answer is probably a lot higher than number 1A because it's more money deposit and a higher interest rate. So So scroll up, I'm typing 260 for N. So 260 for N, 7 for the interest rate. PV is going to be 0. PMT is negative 300. My PY and my CY are okay already. Now I'm going to hit the green alpha button and then hit enter. And I'm going to round that to $112,750, and I'm going to round it to 5 cents. So for part A, it's $112,750, and then I'm rounding the 4.9 cents to 5 cents. The only difference between part A and part B is that the N is going to change, and in part B, the N is going to be 30 times 26, and 30 times 26 is 780. When I get this done on my calculator, the dollar amount is going to be more than 3 times the amount, even though the number of years is only 3 times. So when I eventually do 2b, the only thing that's going to be different on my TVM solver is the n. The n now is going to be 780. The I is still going to be 7. The PV is still going to be 0. Everything's going to be the same. So it's going to be a quick change on my calculator, because I'm just going to change the n and then resolve for the future value. So I'm going to enter everything. Everything's essentially the same. So I just go to my calculator, apps, finance, TVM solver, change that n to 780. Everything else stays the same. Move down to the future value, and then hit alpha and enter, and then all of a sudden you get almost $800,000. That's $795,951, and I'm going to round that to 96 cents. So let me keep this handy. So $795,951.96. So 3 times the length of time, from 10 years to 30 years, that's almost 6 times the amount of money. So if you start saving when you're 25 or 35, as opposed to when you're 45 or 55, you're going to wind up with just a boatload more money, because compounding just works that way. Okay, so our next 2 problems, 3 and 4, I'll do 4, you can do 3. Again, for our problems, I always mess up on the savings problems on the PY and CY, so I'm going to knock those out of the way first. And for this problem, twice a month, the PY and the CY are 24. So I'm going to get my template ready for number 4. So I'm going to have an N, an I, a PV, PMT, future value, PY, CY, leave it on end, and the twice a month part is going to make the PY, CY part be 24. Now dig through the problem. This $300 that's deposited twice a month is an equal recurring deposit, so it goes in the payment. I'm saving up money, so it gets a negative sign. The next number I see is 9.5%. That's a pretty good return. I'll put that in for the interest rate. And the last number I see is 40, and my N is going to be the 40 years, which that 40 represents, times the number of payments per year. I think that's 480. I could actually just on my main screen go right up to the N, and right in the N just type 40 times 24. I don't even have to leave that screen, and it's going to tell me the N is actually 960, so I could do it in my head. So I know everything on my calculator other than I have the 2 blanks, and in this case I'm solving for the amount of money in the future, 40 years in the future, and the other dollar amount, since there's no other dollar amount, it has to be 0. So now when I enter these, 960 for N, 9.5 for the I, 0 for the PMT, 0 for the PV, negative 300 for the PMT, 24 for the PY and the CY, leave my calculator on end, scroll up to the FV and hit alpha and enter, and I get, well, just a boatload of money. $3,286,772, and I'm going to round that to 21 cents. So that's only saving $300. I mean, it's a lot, $300 out of every paycheck, $600 a month, which is $7,200 a year. But $7,200 a year for 40 years, so if you start when you're 25 and retire when you're 65, and you just put $600 away every month, for retirement, and you get 9.5, which is a pretty high interest rate in today's dollars. Historically, that's a reasonable estimate, but right now probably 7.5 is probably a more reasonable estimate of what you might earn over 40 years. But nevertheless, for 40 years, you can start to get a lot of money without saving a boatload. If you're saving this, $7,200, $600 a month, $7,200 a year, that's if you're saving it in a retirement account, that money goes in pre-tax, and that $7,200 that you're saving, you'll probably save, $2,000 in taxes on, and maybe only, even though you're getting credited for $7,200 of savings, had you not saved that money in a retirement tax sheltered place, you'd have to pay $2,000 in tax on that anyways. And so the $7,200 is really only costing you $5,200 because of tax incentives. So the next example is essentially the first few problems with the addition of already having some money saved up. And while you're saving, and that's what this problem is, this is still while I'm saving, the signs are important. Both the PV and the PMT are negative. And this next example is I'm saving up money for retirement. And while I'm saving up money for retirement, any dollar amount that I'd enter in the PV or the PMT is going to go in negative. Nicely, I don't have to get off the TVM solver screen at all in this section. First thing I do in all these savings problems is avoid my mistake. I see the word every 2 weeks. Every 2 weeks, the PY and the CY are 26. So in this example, before I get into the fine details, I want to get the PY and the CY knocked out so I don't mess them up. Now I'll go through the problem, and I'm trying to find the value after 25 years. So I'm not spending, I'm saving. The first dollar amount is an amount that I'm depositing every 2 weeks, so it's a PMT, and while I'm saving, the PMT goes in as a negative. The account already has a balance, that's a present balance of $5,000, so that's a present value, that's its current balance, its present balance, and while I'm saving, both the PMT and the PV get tagged with negative signs. Next number I see is the interest is 5%. Last number I see is find the balance after 25 years. And so I figured out the N, and I could just go to my TVM solver, scroll up to the N, take the number of years, which is 25, times the number of payments per year, which is 26, which the PY is, and you'd get 650 there. And I did the computation up top, but I could do it right on my screen. So if I enter all of those and solve for the future value, I'll get the answer to this question. So first, the N is 650. Second, the I is 5. PV is negative 5,000. PMT is negative 100. I need to get the PY and the CY to 26. Now I'm going to move up to the future value and hit alpha and enter. And I get $146,710, and I'm going to round that to 88 cents. So my answer for this, after 25 years of putting away, well, that's $2,600 a year, 100 times 26, I wind up with $146,710.88 rounded. So the next few homework problems are just going to be this relived. So I get a 6, you get a 5. It's the same problem, and immediately in your problem, you might want to get the PY and the CY. I'm going to get my PY and my CY to be 26. So when I go to do problem 6, I know I need an N, I, PV, PMT, future value, and my PY and my CY are going to be 26 because every 2 weeks is different than twice a month. I think every 2 weeks is more common than twice a month. Now when I go through my problem, the $250 is a recurring deposit. It's while I'm saving up for retirement, not when I'm spending my retirement, so it goes in as a negative. The account already has a current balance of $25,000. That's its present value. And while I'm saving up money, both the present value and the PMT get negative signs. The interest rate is 9%. And the N has to be the number of years times the PY. So the N is going to be 33 times 26. If I just scroll up to the N and type 33 times 26 right in the N, gives me my N is 858. Surprising number. So I'm just going to enter those, and I'm going to solve for the future value. So N is 858, I is 9, PV is negative 25,000, PMT is negative 250, PY and the CY are 26. Perfect. Now I go alpha and solve on the future value. It's over $1 million. So it's $1,800,000, almost $2 million, $813,131. And I'm going to leave that 54 cents. I'm not going to round it up to 55 cents. Probably would have been nice if I put a dollar sign. So 5 should work the same way. And the next two problems, 7 and 8, should work the same way as well. So I'm going to go through problem 8, and immediately I want to bust out the PY and the CY, and the equal deposit. I'm making they're making $1,000 deposit every month, and when you're just getting once a month or monthly, the PY and the CY are 12. So in our problem 7 and 8, the PY and the CY are going to be 12. So I'm going to set it up here. So I'm going to put room for an N, an I, a PV, a PMT, a future value, a PY, a CY, and I never take my calculator off of end in our class. And I'm going to put 12 in for the PY and the CY because you're making one deposit per month. The first amount that I see, the $1,000, that's the deposit that you're making every month. It's the PMT. I'm saving for retirement, so my PMT has a negative sign. The next amount that I see is $100,000, and it's the current balance of that account, and because you're saving money, it gets a negative sign. Last number, well, I see the interest rate of 10%, and then I see 20 years. My N is going to be the 20 years times whatever the PY is, which is 12. And on my calculator, I'm just going to go to the N, and right at the end type 20 times 12, which is the number of years times the PY, and I get 240. So if I enter all of these on my calculator, 240 for the N, 10 for the I, negative 100,000 for the PV, negative 1,000 for the PMT, solve for the future value and put 12 in for the PY and the CY. So I get 10, negative 100,000, negative 100,000, change the PY and the CY to 12, get up to the future value, and then hit alpha and enter, and it's going to give me $1,492,176. That's 19.9 cents. I'm going to round it up to 20 cents. So you can get a lot of money saved up for retirement if you give yourself a lot of time. Here, 20 years isn't a lot of time, but this is clearly someone that's already been saving for a long period of time, because you're not going to get $100,000 if you haven't been saving for a pretty good length of time. Okay. So the next problem is, it feels realistic to me. Joe wants to have $1 million when he retires in 25 years. He doesn't have any money saved up, but he wants to start trying to put money away so he can get to that $1 million. So he wants to know how much he needs to get yanked out of each paycheck, if his money can get 8% interest on average, and the interest is paid twice a month to get there. So, kind of worded a little clunky, but I'll try to do this. So, immediately, I want to get the PY and the CY fixed up. And Joe is going to make deposits twice a month, and for twice a month, the PY and the CY are going to be 24. So let me get this started so I don't mess that up. So we have an N, an I, a PV, payment, future value, PY, CY, and end. And in this problem, because Joe gets paid twice a month, the PY and the CY are 24. Now, I'll go through the problem and just kind of pick one number at a time. The first amount that I see is $1 million, and that's the amount of money Joe wants to have 25 years from now in the future. So that's a future value, and future value, fortunately, that we don't have to vary signs. Future value is always positive. So any amount that I put in a future value is always going to be positive. So Joe's saving up money, but he has a goal. His goal is to have $1 million in the future, and regardless of whether I'm spending my savings or I'm saving up money, the future value, don't have to worry about its sign, it's always positive. So Joe's $1 million goal in the future is going to go in the future value. The next number I see is the number of years, and I use the number of years to get my N. The N is the number of years times the PY. So my N is going to be 25 years that he's saving up times the PY of 24. And again, I just go up to the N, get my cursor flashing there, and I type 25 times 24 in for that, and I get 600 for the N. So I got through the $1 million, I got the 25 years done, I got the PY and the CY. Next thing I see is 8% interest rate. That's going to go in for the 8. And then I have $2 amounts left and no other dollar amounts left in the problem, which means one of them is 0 and the other one I'm solving for. And in this case, Joe's trying to find out how much money to get pulled out of his check, essentially, and he's figuring out his PMT. So I'm solving for how much I'm supposed to get out of my paycheck, and I'm going to be making the same withdrawal for 25 years. So the other amount, because there isn't another amount, it has to be 0. Now I'm going to pop these on my calculator. So N is 600, I is 8, PV is 0, PMT is I'm solving for it, future value is a positive 1 million, PY and CY are 24, I go up to the PMT, hit my green alpha button, and then enter, and he needs to make a deposit, and I'll round it, of $523.74. My calculator puts a negative sign with it to indicate that's money that Joe's spending, but in my answer I don't need to put a negative sign with it. The signs are only important so the calculator can get the right answer. It's not. I'm never going to tell somebody you have to deposit negative $523.74 every 2 weeks with your paycheck, which is a little over $1,000 a month, about $12,000 a year. So putting $12,000 a year approximately away for 25 years and getting 8% interest, you can end up with $1 million. That's reasonable. 8% interest over 25 years is probably a fine interest rate to estimate. The next page just does the computations, and then we get our problems. So I get 10, you get 9. I'll try to squeeze my 10 in. So I'm going to make room for an N, an I, PV, PMT, future value, PY, CY, and end. And as I go through this problem, I want to get the PY and the CY, and it's buried way low with the PY and the CY. That's every 2 weeks. So my PY and my CY are going to be 26. And the only reason I do those first is because I mess them up a lot myself and just want to keep that mistake from happening. So go through the problem. The first dollar amount of $750,000, that's her future retirement goal. That goes in as the future value. And always future value goes in positive. So $750,000 is the future value. The 35 is going to give me the N. My N is going to be the 35 years times the PY of 26. So I'm going to go to my calculator, type in 35 times 26 in for the N, and I get 910. Next number I see is 7% interest rate, so the I is going to be 7%. Then I have everything in but 2 amounts, but I don't have any amounts left, which means one of them needs to be 0. And Sue's trying to find out how much her recurring deposit needs to be, so we're solving for the payment, which means the PV is 0. So now I'll enter this. I have the N okay, so the I is 7%, and then I'm solving for the payment, so I can leave it alone. I'm going to put $750,000 as her retirement goal. Change the PY and the CY to 26. Scroll up to the payment and alpha solve it. And Sue's going to have to deposit, not so much, $191.39 to get $750,000, but she has 35 years to do it. So if you start saving when you're 30 and you retire when you're 65, and 7% is a very conservative estimate for an interest rate. So basically, what's that? It's about $400 a month, because give or take, I mean, approximately that, to get up to that $750,000. 11 and 12 should work the same. So I'm going to make room for 12. I'm going to make room for my N, my I, my PV, my PMT, and I have future value, PY, CY, and end. For our problems, the CY and PY, your number 11, the PY and CY is not the same as my 12. In my 12, the PY and the CY are 26. So I get those knocked out of the way in these savings problems because it just helps me out. First number is the $500,000 that Shelly wants to have up in the future saved. Future value is always positive, so I don't have to worry about the sign. I'm going to put $500,000 in for the future value. The 15 years is going to help me get the N. The N is the 15 years times the number of payments per year, which is 26. So I scroll up to the N. I type 15 times 26 and hit enter, and I get 390 for the N. The only other, so I've got that number done, that number done, that done. The only other number I see is the 8%. There's only one number left, and there's 2 spots. So, and I'm solving for the PMT, which makes the PV 0. So I'll just enter these up. Put 8 in for the interest rate, 0 in for the PV, 500,000 for the future value. My PY and CY don't need to be changed because they're the same as the last problem. I'm going to solve for the future value, or payment should I say, and it's going to be $664.85. So to get to $500,000, which is less than the last problem, I have to put about $1,300 or $1,400 away a month because I only have 15 years. When you crunch the time, it's a heck of a lot harder to grow to a big dollar amount. The next two problems are still saving up money for retirement, or the next problem is still saving up money for retirement. But unlike the last group of problems, this person already has some money saved up that we need to take into consideration. So when I go through this example, again, for each of the problems in this section, I'm using the TVM solver screen. And I see twice a month here. And when I see twice a month, the PY and the CY are 24. So I'd like to knock those out first. And now I'm going to dig through the problem. The first amount, the $1 million, is what Joe wants to have saved up in the future. It goes in the future value, and future value is always positive. Can't know if I can fit it. So $1 million goes in for the future value. The next amount I see is 25, and that helps me find the N. The N is going to be the 25 years times the PY, which is 24. Apparently 25 times 24 is 600. Again, it's easiest just to scroll up to the N to do that computation. So I can just go to the N and go 25 times 24 and get the 600 that I need. So I did that amount, that amount. The amount of money already saved up, that's the present value. And while you're saving, present value is negative. While you're spending, present value is positive. Here, I'm trying to save up to $1 million. I'm not done saving, so I'm not spending my savings. So the present value is going to be the negative of that. It's the amount of money already saved up. That's the current value in that account. And while you're saving, it needs to have a negative in front of it. The only other number I see is the 8%, which is the interest rate. Fortunately, I have numbers in for everything except one, and that's what I'm going to solve for. So N is 600, I is 8, PV is negative 25,000. Payment I'm solving for, future value is $1 million. PY and the CY are 24. I go up to the PMT, hit my green alpha button, and hit enter. I get $427, and I'm going to round that to 31 cents. So this is almost exactly like the last group of problems, other than we have to add the amount already saved in as a positive, or negative, should I say. Okay, so 13 and 14. So they should work the same way. For me, the PY and the CY are going to be 26. I think I'm just going to write these horizontally here. So I'm going to write N, I, PV, PMT, future value, PY, CY, and end. And for me, the PY and the CY are going to be 26 because every 2 weeks gives me a 26. Now I go through the problem. First number I see is the 750,000 that we want to have in the future, and while your future value is always positive, so 750,000 goes in as a positive. Next number I see is the 35 years. My N is going to be the 35 years times the PY, which is 26. I usually do that right online, so I'm going to go up to the N, type 35 times 26, and I get 910 for the N. So I got that number done, that number done. The amount of money Sue already has saved up, it goes in the present value, and she's still saving up for retirement, so that present value needs to go in as a negative. And I did the every 2 weeks already. 7% is the interest rate. I need to solve for the payment. So if I enter all those and solve for the PMT, I should get the right answer. So N, boom, I is 7%. PV is negative 20,000. PMT I'm solving for. Future value is 750,000. And 26 is a PY and CY. I scroll up to the PMT, green alpha, and enter. And I get $132, and I'll save 44 cents. So here it's $132.44. 15 and 16 should work just about the same way. So I need to make room for an N, an I, PV. My guess is I'm solving for the PMT. Need a future value, PY, CY, and I leave my calculator on end. I see every 2 weeks, so the PY and the CY are 26 twice a month, like you have. The PY and the CY are going to be 24. So, rushing through the problem, first number I see, 500,000, is what she wants to have saved up in the future. That's the future value, and future value always gets a positive if it gets a dollar amount at all. 15 is the number of years, so the N is going to be the 15 years times the PY, which is 26. Do that right in line. So N is 15 times 26, and I get 390. So I've done that number for the future value. That helped me get the N. The amount of money already saved up goes in as the PV, and it has to go in as a negative because I'm still saving up. The only other number I see is the 8% interest rate. And that's everything I need, and I'll solve for the payment. So N is 390, interest rate is 8, PV is, you can't even see it, but it's negative 75,000. Payment I'm solving for, future value is positive 500,000. PY and CY are 26. Go up to the PMT, alpha, and solve it, and I get $334.35. So I think the rest of the problems are drawing money out of retirement. So so a person is retiring, they have this much money in their account, they're going to start spending it. And while I'm spending down the retirement, that's the rest of the section. So for the rest of the section, because when we're spending our retirement, as opposed to saving up, the signs on the PV and the PMT start to get different. So when I'm spending my retirement, the PV is now going to become positive. I think the PMT is still going to be negative. That makes sense because they're going in opposite directions. While you're saving, they're both negative. While I'm spending, as I'm trying to think to myself right now, it almost feels right. Oh, because I'm solving for it. Duh. Won't matter. All right. For now, let me hold off on that. But when I'm spending my retirement money, the PV is definitely positive. And when we get into a problem that has a payment that we need to enter, then I'll focus on the right. I'm pretty sure I have that right there, but I need to see a problem to make sure that's the case. So here's a person, they have $575,000 saved up. When you're retired, you get more conservative with your investing, and their interest rate now is just 4%, and they're going to make monthly withdrawals. For whatever reason, when people retire, it's more common to get a monthly paycheck. Social Security comes once a month, and they want the money to last for 30 years. So if you retire when you're 65, this will let you take money out to your 95, and it would be nice if you live longer. But then this is going to run you out of money. So my goal here is I have this person has $575,000 saved up, and after the end of 30 years, all their money's going to be gone. And they hope, well, it'd be nice to outlive your money, but if they don't, then they'll hopefully have good kids to help that out with the rest. So in this problem, they're going to make monthly withdrawals, and when you make one withdrawal per month, the PY and the CY are 12. So that's the first thing I try to nail. Then I go through the problem. The first amount, the $575,000, that's what they presently have in their account when they go to retire. It's a present value as opposed to a future value. It's what they're going to start living off of. And it goes in as a present value. And while you're pulling money out for retirement, it goes in as a positive. So that number's gone. The next number, the 4%, must be the interest rate. And the last number is the 30. That'll help me get the N. The N is always the number of years times the number of payments per year. So it's 30 years times the PY, which is 12. And that comes out to be 360. But I can just go right to my N. You can't see when I do that. And type in 30 times 12. And get the 360 that I need. So I've used up every number in the problem, but I have two unknowns, which means one of the unknowns has to be 0. And in this case, we're planning on the money running out after 30 years, which means the future value is going to be 0. And I'm going to solve for the PMT. So if I enter these, I'll find out how much they can pay themselves every month. So 360 for the N, 4 for the I, 575,000 for the PV, 0 for the future value, PY and CY are 12. And then I'll go up to the PMT, hit alpha and enter. And so they can get $2,745 a month for 30 years. That's without giving a raise. If you want to factor in giving a yearly raise, the calculator, it's beyond what the calculator could do. Then you need to break out some sort of Excel spreadsheet or some pre-programmed software, some software that will help you figure out something more complicated if you want to start giving an annual raise to yourself. So, but for 30 years, you can spend $2,700 a month, and if you get a 4% interest rate, and at the end of 30 years, you'll be out of money. So the next two problems should just be this again. So I'll do 18, you'll do 17. And they're going to be making monthly paychecks to themselves. Again, that's probably common in retirement, just to pull money out once a month. So my PY and my CY are going to be 12. The first amount I see in problem 18 is the $1 million. That's what they currently have when they sit down to retire. So that's going to go in as a PV. Next number I see is the interest rate of 3.5%. And the only other number I see is the 30 years. The N is going to be the 30 years times the 12 payments per year, which I believe is 360, but I'll do it right in line. So go and do 30 times 12, and I get 360 monthly checks. I have all the information from the problem in input, and $2 amounts left, which means one of the two needs to be 0. In this case, the future value is going to be 0. We're going to spend down all the money. Now I enter this the best I can. So 3.5 for the interest rate, $1 million for the present value. Everything else is okay. I'm going to alpha and solve to get the how much they're going to pay themselves, and it's $4,000. That's a nice check. $490 and I'll say 45 cents. They can pay themselves once a month, so that's almost $50,000, more than $50,000 a year, which right now is a lot of money. In 30 years, unfortunately, it probably won't be a lot of money. All right, 20, and you can do 19. And most of my spending of my retirement problems, people are getting monthly checks, so my PY and my CY are going to be 12. In problem 20, the first dollar amount I see is a $400,000. That's the amount that they already have saved up. PV is positive when you're spending your savings. 3.25% is the interest rate. My N is going to be the 32 years times the 12 times per year. So I scroll up to my N and do 32 times 12 and get 384. I've entered every amount from dollar amount from the problem. The one that has to be 0 in this case is the future value, and I'm solving for the payment. And I get $1,676.86. I couldn't live on that now. And the hopes would be, if this is your retirement, that you get Social Security to kind of supplement that, you know, about $1,000 a month or so, or I don't know. I think my parents get like $1,300 a month each in Social Security, and then maybe you can do it fine. But $1,600, it would be, if you're living by yourself, that would be not living, you know, really, really comfortably. I can't imagine with health bills and any sort of house payment would be tight probably. All right, next kind of example. So this person has this much money saved up, and they're going to spend $3,000 per month because that's what they need to live on. Question is, how long is their money going to last? And it's not very hard on my time value money solver. So I'm going to set up for this. So N I P V. PMT, future value, PY, CY, and I'm never taking my calculator off of end. And this person is going to pull out money each month, so the PY and the CY are going to be 12. It's not every 2 weeks or not twice a month, so I don't have to worry about that. As I go through the problem now, the $750,000 is the amount that's in the retirement account when they retire, and this is what the starting amount that we're going to pull from. And PV, when we're retired and withdrawing money from our retirement, goes in as a positive. The next number I see is 4%. That's going to be the interest rate. So I've got that done, that done. The next number I see is $3,000 per month, and that's a recurring withdrawal. And when you're withdrawing money, it also needs to go in as a negative. So the PMT is always going to be negative. That's not going to switch. I might have said something different at the beginning, but for our it can switch, but in our class it's not going to switch. It's going to be negative again. future value and N are the two things that I don't have values in for, which means one of them must be a 0. And I'm trying to actually solve for N. How long will my money last? It better not be 0 months, so the 0 must be the future value. I'm trying to do this. N is what I'm solving for, so I don't need to type anything there. I type 4 for the I, 750,000 for the present value, negative 3,000 for the payment. Everything else is okay. Go up to the N, hit alpha and enter, and that tells me that it's going to be 538, it's a long time, 538.42 months. That's a boatload of time. If you take that number and divide it by 12, if you do like 538 divided by 12, that tells you it's 44 years. Dividing months by 12, you get years. So for an answer to this, it's 538.42 months. I'll say over 44 years. So that person probably could take out more from their account, or they'll likely have money left over for somebody to inherit. Okay, so 21 and 22. We've got to be getting close to the end. These are the last problems. So I only have one more to do. You have two more to do. So, for me, a person has $100,000 in their account. They need to withdraw $2,000 a month at 3%. How long will their money last? So I have to set up an N, an I, a PV, a PMT, future value, a PY, a CY, and an N. And they're giving themselves a monthly check. So the PY and the CY are 12. The $100,000 is the amount that they presently have saved up when they retire. The 3% is the interest rate. It goes in as the I. The $2,000 is the amount that they're withdrawing, and payments have to go in as negatives when we're spending our savings. I have two values left, an N and a future value, and I can't put a 0 in for the N. That means my money would last 0 months. That's no good, so my future value is going to be 0. And now I'm going to solve. So my N I'm solving for. The I is 3%. The PV is $100,000. Too many zeros. That's good. PMT is negative 2,000. Scroll up to N and solve for it. And I get, it's not that long at all, 53.48 months. That's not good. So if you need $2,000 a month, 53 months, that's what? So if I do 53 divided by 12, it's 4.4 years. So although $100,000 sounds like a lot of money, I mean it is a lot of money, but if you're pulling $2,000 a month away to live on, then it's only going to last you 4.5 years, and that probably won't get you through your retirement. Hopefully, it won't get you through your retirement. So as you start to think about saving for retirement, this is clearly an unrealistic amount. And I'd be more than happy to sit down with you and you can bounce things off my head. I can give you some ideas. I used to be an accountant, and I like money problems. I might give you some ideas, but really, if you're serious about saving for retirement, then talking to somebody that does it for a living is probably a great idea. So hopefully you're able to do 21, and then you have one more problem. I don't have another problem, but 23 is going to solve just like 22 did. So you should take us, pause the video and do that, because I'm about ready to shut the video down and go do a hike, even though I think it's 34 degrees this morning, so it's going to be not a pleasant hike, to say the least.